Hello everyone, welcome you all. So in this video, we are going to discuss about the trigonometric ratios in different quadrants. Okay. In the previous video, we have discussed about the 6 trigonometry ratios. Okay. Now in this video, we are going to find this 6 trigonometry ratio in different quadrants. Okay. Let's start discussion with the first quadrant. So as we know, this is X and Y. These are the two axes. They meet at point origin. Okay, with the center as origin, we have drawn a circle. Okay, now this is a arbitrary point P x comma y in the first quadrant. As we know, this x and y axis, which are mutually perpendicular to each other, divide the plane into 4 quadrants. This is our first quadrant, this is our second quadrant, this is our third quadrant, this is our fourth quadrant. Now in this video, we are going to discuss 6 trigonometry ratios in different quadrants. Okay, now with center, we have drawn a circle with a radius OP. Okay, with the radius OP, OP is the radius of the circle. Okay, now what we'll do, we will drop a perpendicular from point P which meet at X. So I will drawing a perpendicular like this. Okay, which meet at X axis. So you can see here, if I join this also, so it will become like this. So we will mark this point as A. Okay, now you can say OPA is a right angle triangle. Now we have considered this OP with x-axis which make an angle theta. Okay, now I think you have got the clarity about this OPA triangle. I will repeat one more time. OP is the radius of the circle. From the point P, we have drawn a perpendicular which meet at x-axis. So and it is OP is inclined with angle theta with the x-axis. Now look at what is OA. OA we will consider to be as x distance, x, and PA we will consider to be as y distance. Okay, this is horizontal x and this is our vertical y. Okay, now if angle theta is here, so let us name these sides. Okay, now OP is the slant line of the higher right angle triangle, so it is called what? Hypotenuse. I am writing as HYP. Hypotenuse is our OP. Okay, now see this PA side, which is opposite to the angle, it's considered to be as opposite side. Okay, this is our opposite side with respect to the angle. Okay, now OA, which is the adjacent to the angle, it is called as adjacent side, which is adjacent side. I hope you have understand this. Okay, now let us find the ratios. Sin theta is nothing but it's the ratio of opposite by hypotenuse. What is opposite here? Opposite is y. And hypotenuse is what? R, y by r. So sin theta is nothing but y by r. And we know that in first quadrant, this x direction is also positive and y direction also positive. Okay, in first quadrant, x is positive, this also positive. In second quadrant, this is negative and y is positive. In third quadrant, x also negative and y also negative. In fourth quadrant, x is positive and y is negative. So we are considering about first quadrant. So in first quadrant, both x and y both are positive. Now let us talk about cos theta. Cos theta is nothing but it's the ratio of adjacent by hypotenuse. So what is our adjacent side? That is x and hypotenuse is r. So x by r. Okay. Now sin theta is y by r. Cos theta is x by r. What about tan theta? It is the ratio of opposite by adjacent. What is opposite side here? Y. And adjacent side is x, y by x. Okay, if you divide this, you will get this r gets cancelled, we get y by x. So in this way, we are going to frame the trigonometry ratios with respect to quadrants. We know that cosecant is the reciprocal of sin theta, so we can write as r by y. Similarly, secant theta can be written as is reciprocal of cos theta, it can be written as r by x, and cot theta is the reciprocal of tan theta, it can be written as x by y. Okay, now what you have observed? We have observed that in first quadrant all these are x and y are positive, therefore all our 6 trigonometry ratios are positive in first quadrant. Okay, and the first quadrant angle ranges from what? 0 to 90 degrees. So I can say that in 0 to 90 degrees all 6 trigonometry ratios are positive. Okay, in the first quadrant, all 6 trigonometry ratios are positive. That angle range from 0 to 90 degrees. Now let us talk about second quadrant. Now let us discuss the angle in the second quadrant. Okay, so now you can see here our angle is in second quadrant. Say this is our PAO is a right angle triangle, or OP is the radius of the circle, and this is X and this is our Y. Now we have to what? We have to again find our 6 trigonometry ratio with the help of this assigned angles. Now let us talk about sin theta. It is opposite by hypotenuse. So what is opposite side? Let us consider. So this is our theta, means again this is our adjacent sides. Okay, now this is our opposite side and this is our hypotenuse. Okay, now what is opposite side here? Opposite side is nothing but y, and we know that in second quadrant y is positive and x here is negative. So y opposite y by r, y here is positive and x here is negative. Okay, here there is no x is there, so sin theta is equals to y by r, and the reciprocal of sin is cosec, so I can write directly as r by y. Now similarly cos theta is the ratio of adjacent by hypotenuse. So what is adjacent side here? X, and hypotenuse is what? R, and we know x is negative in second quadrant, so I am writing as negative. Why negative? We know that x is negative in second quadrant. Similarly tan theta is the ratio opposite by adjacent. Opposite here is y and adjacent here is x. Again x is negative, I am writing as negative. Similarly second theta is the reciprocal of cos theta, so I am writing as minus r by x. Similarly cot theta can be written as negative of x by y. Okay, so now this is the 6 trigonometry ratios in the second quadrant. So what you conclude in the second quadrant? In second quadrant the angle ranges from 90 to 180. Okay, in 90 to 180, and the angle lies in the second quadrant. Only sine and its reciprocal cosec is positive, remaining for are negative. So we can conclude that in second quadrant only sine and its reciprocal is positive, remaining 4 are negative in second quadrant. Okay, now similarly we will talk about third quadrant and fourth quadrant. Now let us discuss the trigonometry ratios in the third quadrant. As you can see here, our angle lies in third quadrant. So again this is OP is our radius of the circle, and this is our A. Okay, OA is x and OPA is our y. Okay, so now again we have to frame this 6 trigonometry ratios, but we know in third quadrant you can see here both x is negative and y also negative. So opposite side is how much? Again opposite side is y and hypotenuse is r. Again y by r, I am writing negative. Why negative? Because we know the y is negative in the third quadrant. Similarly cosec theta can be written as minus r by y. Okay, similarly cos theta is adjacent. What is adjacent side here? X by hypotenuse r, and I am writing negative. Why negative? Because in third quadrant x is negative. Similarly here secant theta can be written as minus r by x. Now tan theta is opposite by adjacent. So what is tan theta? Opposite side here, opposite side is our y, minus y by adjacent is our minus x. So here minus gets cancelled, we can write as y by x. Similarly cot theta can be written as x by y. So what you have concluded, if theta lies in third quadrant, only tan and cot are positive, remaining these 4 are negative. So in third quadrant, when the theta lies between 180 to 270, if the theta lies between 180 to 270, only the tan and cot is positive and remaining all 4 are negative in third quadrant when theta lies between 182 to 270. Okay, similarly we'll check for fourth quadrant. Now let us discuss about the in fourth quadrant. If theta lies in fourth quadrant, what about this trigonometry ratio? So you can clearly see here our theta is in our fourth quadrant, and I think you are familiar with this x and y. So I'm writing this is our hypotenuse, this is our opposite side, and this is our adjacent side. Okay, so now we have to frame sin theta. In fourth quadrant we know x is positive, okay, and y is negative. X is positive, y is negative in fourth quadrant. Okay, so now opposite by hypotenuse again is our y by r. We know y is what? Y distance from x axis, that is y, it is negative in what? In fourth quadrant, so minus y by r. Similarly cosec theta can be written as minus r by y. What about cos theta? adjacent by hypotenuse. Adjacent side is x, hypotenuse is r, x by r. In fourth quadrant, x is positive, so it will become positive. So secant theta can be written as r by x. Similarly, tan theta can be written as opposite by adjacent. Opposite is here is y, that is minus y, by x here positive, that is x. Okay, cot theta can be written as minus x by y. So what you have concluded, if theta lies in fourth quadrant, the angle between 270 to 360 cos and its reciprocal secant is positive, remaining 4 are negative. So in fourth quadrant, only cos and its reciprocal is positive, remaining all 4 are negative in fourth quadrant if the theta lies between 270 to 360. Now let us recall what we have learned in simple and easy way, that is all students take care. So what we have done, we have divided the quadrant into 0, 90, 180, 270 and 360 angle. First quadrant we name as all, second quadrant S for students, T for take third quadrant, C for care in fourth quadrant. Okay, all means here all these 6 trigonometry ratios are positive in first quadrant, means 0 to 90 degrees, all these 6 trigonometry ratios are positive. Okay, coming back to second quadrant, S stand for sine and its reciprocal cosec. They both are positive in second quadrant, remaining these 4 are negative in second quadrant. It is easy to remember. Third, we have T for tan theta and it is reciprocal cot theta. These both are positive in third quadrant, remaining these all 4 are negative in fourth quadrant. Okay, now here C for care for cos theta and its reciprocal secant theta. These both are positive in fourth quadrant and remaining 4 are negative in fourth quadrant. Okay, so in this way we can memorize this all student take care. Okay, I hope you understand this video. Thanks for watching.